All right, friends and neighbors, welcome back to another networking video. Today we're going to be going through how to set up the hard phones, the Cisco and Avaya phones. Actually, technically, we're going to do one and not the other today, just on time, I think. But to set it all up in the lab, and we've got a bunch of stuff working. So I'm going to show you the output of all of that stuff, not necessarily at in progress because that's kind of tough to capture, but I will show you everything that I went through and a couple of cool tips and tricks along the way. So here we go. All right, remember that the whole goal here is that we've got this free PBX SIP server running in a VM, and we want soft clients. We're doing Lin phone, and then also a couple of hard phones to connect to our SIP server. So that's the goal, and at this point we've gotten to the hard phones. But of course we want them to be SIP clients, but that's not what they are. The Cisco's want to do SCCP, or Skinny, the Skinny Client Control Protocol, and the Avayas want to do H.323. Now H.323 is not what you actually see in Capture. H.323 is the umbrella protocol. H.225 is what you'll start to see in Capture, sometimes 245 depending on what you're doing. Okay, so that's how you sort of know what your phones are up to. That's actually revealed to us in Capture, but we'll cross that bridge here in a minute. So what do we have to do? Well, we're going to set up a topology. This is a packet tracer image, right? This is what I set up in packet tracer, but I actually have this in the lab. I've got a router that's running a DHCP server. And then on my laptop, so I could sort of capture what's going on there, is the TFTP server. I'm using SolarWinds for that. And then I've just got a couple of phones connected to a switch. Now in the lab, the switch is offering power over Ethernet, and that's one of the fun things that I'll show you here in Packet Tracer. So let's take a quick look at that first. So here is the topology that you just saw in Packet Tracer. And so this is really straightforward. I'll show you the DHCP config that I have on the actual router here in a second. But what I wanted to show you on Packet Tracer is this. If I take a phone and we go over here and we grab an IP phone and I just connect it to the switch, right? Whoops, not what I want to do. First of all, it gives you two choices here. You can do a switch or the PC. That's because a lot of phones internally are mini switches, 3-port switches. So we actually want to connect to a switch. So we'll see how that works. So now I'm going to go to some port on the switch, and I can see that this is down. There's nothing happening on this. So what I have to do on the phone, and this is what you do in Packet Tracer, is you say, okay, here's the power adapter, and what it's saying is that the phone is not connected. It's not actually powered up. So in Packet Tracer, what I have to do on some of these devices, it's not just the phones, is I got to take my power adapter and I'm going to plug it into the adapter, and we can see that now the phone comes up. Okay, now that's not always the case. If I scroll over here and I have another phone, right? And then I connect it to, this one happens to be a 3560, and a 3560 has power over Ethernet capability. So depending on which model of switch you use in your packet tracer topology, you'll either have to provide power to it, as you would in real life, or you can get power over Ethernet from the switch itself. All right, let's take a little closer look at this one. And you can see that I've got a PC behind this phone right here. That is a very common deployment model because we want to save ports on the switch. And so the phone itself is acting as a small switch passing through the phone, or passing the PC's traffic through the phone. So if I was to do the same thing here, I have a PC, and then I was to click to the PC, I would just do this, and you can see that it comes up right away, right? Now this is not power for the PC, this is just the data connection. Now what that also means is that out here on the switch, a lot of times we have more than one VLAN feeding a port. Okay, whoops, a port. And this is where we get into the whole idea of, I mean, you could trunk, that's the obvious answer, but what we actually do is what we call the voice VLAN. So on a switch port, we know that we can put a port in a VLAN, but when we use also the voice VLAN, what that does is it supports two VLANs going to a particular port. So if I was in the switch and I would say, you know, switch port access VLAN whatever, and then I would say, okay, the voice VLAN will be some other VLAN, then what the Cisco is looking for is a VLAN that's just for voice and then a VLAN that is for data. Okay, so that's just the fun thing in the in Packet Tracer. Sometimes you have to actually turn on the device that you're worried about because you're not getting power over Ethernet from a particular switch. This is a 2960, but the 3560 does actually provide PoE. Okay, so that's enough with Packet Tracer. Let's go back and look at what we were doing. Now, when we're upgrading, we have to be conscious of how the phones learn about their parameters. And so we now know that the order of operations goes DHCP, TFTP for some clients, especially for hard phones, and then you're going to actually talk to the VoIP server. Now, how do you learn about the VoIP server, or for that matter, what your settings are supposed to be? Well, you can do it manually. You can go into a phone, just like a soft client, and say, this is how I want you to do things. On the other hand, we could bring something down from the TFTP server and tell us what our settings are. Now, there's actually two things that we want to do with our TFTP server. One is we want to provide the upgrade files. So we are going to be flashing these over to SIP. And so the TFTP server has to have all of the files necessary to turn a skinny or an H.323 phone into a SIP phone. But on top of that, we need sometimes settings. So an example of something that might be in a settings file is the location of the call server. And then whatever options, you know, language options, menu options that you have on a phone. Now, depending on what you are using or which system you're on, right? So if you're Avaya, then very commonly you're going to use option 176 in DHCP. Well, what's that for? So the first thing that you do is DHCP. And in the offer for DHCP, and we'll actually take a look at what that looks like, you're going to have the TFTP server and maybe the call server in there. If you're on Cisco, very commonly you're going to use option 150 for that, which is the TFTP option. But also, there are systems that use option 66, option 120, option 125 for these things. So if you've spent any time with DHCP, you know what options are. If you haven't, go look at the other DHCP videos that I did, and you'll see exactly what we're talking about. Okay, so that's our order of operations. That's what we're going to do. These are actual lines from an Avaya DHCP-based server, or I should say that a DHCP server that was living on an Avaya topology. And this is an actual line from a Cisco topology. All right, so let's talk Avaya first. Before we start DHCPing and before we start TFTPing, I think it's a really good idea just to reset the phone. So if you go out on eBay or to Amazon and buy yourself a bunch of phones, which you certainly can do, a lot of times you won't have the files, you won't have the configuration, you won't have the manual, etc., etc. So what I always do with a phone when I'm bringing it into the topology is you'll boot it, right? You get a PoE connection to the switch and you'll boot the phone. And before the interface comes up, you hit mute 73738 and then the pound sign. And what that does is it resets the phone. Now, you can also go through a series of options, but if you don't want to change anything, you just say, all right, go ahead and restart the phone. And that's what you see in this image here, although it's kind of tough. I tried to take a picture of the interface. It's challenging to get a picture through their screen and get clear test. But this says restart the phone, and then you hit either the asterisk for no or the pound sign for yes. So you reboot. And so it cleans out everything. And then at some point, you can reset the phone. You can do the same thing, but as it starts to come up, it's sitting there and it's waiting for you to tell it what to do. You can hit mute 744#. Now, this is a really straightforward way to tell it what the signaling protocol is going to be. And you can see here that I changed it to SIP. And so, again, you hit that key combination, and then you say, I'm going to change it, and then go to SIP, and then say, OK. Now the phone is going to reboot, and what it thinks it's trying to do is be a SIP phone instead of an H.323 phone. Now it's also going to go out to the TFTP server at this point and say, all right, give me all the SIP stuff. And that might be the binary files that tell it how to do SIP, how to work through SIP, and then also the settings for your particular network. So let's talk just briefly about the TFTP server. So maybe I show this to you real quick. I am working with Cisco and Avaya phones. And the nice thing is that because Avaya phones are looking for the settings.txt file, the upgrade program, and then bin files or binary files, and the Cisco is not. The Cisco is looking for the loads files, the SBN files, some XML files, some type length value or TLV files. They can coexist in the same directory. They don't have to, but they can coexist in the same directory. And you just tell your server, your TFTP server, to point to this particular directory. Okay, so that's the directory for my SolarWinds TFTP server. By the way, that was free download. So here we go. We can see that, right, it connects. In this case, it's 1.15 connects, and it pulls down the settings file and then works through the upgrade. Now, sometimes it needs to pull down the upgrade program, but so sometimes they'll be flopped, but it's not a big deal. And then it says, okay, you told me that I was going to be SIP. Let me get the bin files for that. And then I'll reboot and check everything if necessary. And this is pretty much where this phone stopped. And we can see that you can actually take a look at the phone screen and see what file it's pulling down. And this also tells you where it is in the process. Now, another way to go about this is to say, well, I've got this set up. What's happening on the network? And I always like to set up, some kind of monitor session to see what's going on. Because if things break, I want to be able to, have a little more information when I'm troubleshooting. So let's take a look at a capture. Now this is an early capture, so this was when I was doing the Cisco's, but we'll use this as an instruction sort of thing. So if I look at the offer right here, right, so a phone comes up and says, hey, I'd like an IP address. Here comes the offer from the server, and we can see all of the options here. Now I take a look at this and I see option 150, and that tells me that this is probably something Cisco-ish. And so if we look at the options, right, there is my TFTP server address. That's what this particular option does. Now this is also an IP address, so the hexadecimal down here is specific to this particular IP address, C0A80163. That's the hexadecimal representation of 192.168.1.99. And then we've got the regular DHCP options. Okay, so let's do the one that was specific to the Avaya. And I'll show you a handy tool in Wireshark if you're not familiar. Right? If I want a particular frame number, you can see I was doing this earlier. You can say I just want to go to this particular frame. Now this is tens of thousands of packets, and so sometimes that's just easier. Now if I get rid of this also allows me to, I'll be close by there. So here is this particular packet. Now the reason I wanted to show you this one is because this is what the Avaya was trying to do at the start. So this also tells me whether or not I needed to flash it to SIP or not. If this doggone phone says, hey, I'm going to go out there and look for an H.323 PBX, then I know that I'm not getting ready to SIP. And so H.225 is part of the H.323 suite of protocols. Okay, so let me see. The next packet I wanted to show you was just a little farther down here. Take a look at 58. Now here is the DHCP offer. Now remember, at this point, I said, well, it's time to support the Avaya phones in the same topology. So the Avayas want option 176. So now if I come down here a little farther, we can see that we've got a lot of the same options, but if I keep going, there it is. There's option 176. There's another option. I configured it. I wasn't actually using this. We'll collapse a bunch of these that we don't care about. Okay, so here is, we can get rid of the router one too. Here is option 176, and this is specific to an IP telephone. You can see that. Now the difference between this and option 150 is that this is an ASCII string. So Wireshark knows how to decode this. Now, if you had an ASCII table in front of you, you would know how to decode this as well. So, but if I click on this, I can see that it's the same thing that I had in the earlier slide, right? The TFTP server is this value, 192.168.1.99, and my call server, which isn't actually active on this particular topology because I'm just worried about the SIP files, is 1.254. So this is what I was passing with option 176. All right, let's go to 699. There we go. And right there, you can see now TFTP is called the Trivial File Transfer Protocol. It's very commonly used in support of network devices. This is as opposed to FTP, File Transfer Protocol, or SCP, Secure Copy, right? So we don't want to encrypt and we don't want to have usernames in a lot of these. Now, these are internal transmissions, right? So nobody should be able to really see them. And even if somebody was able to see them, they're not going to get very much out of this that they couldn't have gotten from a DHCP message. Now, that said, right, what we want the phones to be able to do is come up and just talk to a TFTP server without having a password and login. Here we can actually see the settings file go across. Now, the settings file and a lot of the binary files can be actually quite large. I don't know if you can see this, but there's a lot of light blue on this side here because there's a tremendous number of packets that were going between the TFTP server and the phones at this point. And we'll see here in a second. Let me see. Yeah, we'll do that. We're just going to go down and visit another file real quick here to show you. I mean, this is all the settings file, right? What am I after? 134. Oops, right by it. And here is one of the binary files. Now remember that the phone thinks that it's trying to do SIP right now. And so what we need on the TFTP server is the right binary files that you need to support SIP. So to turn this over, and so it understands all the methods required of SIP. Okay, and the last one I have, and we'll actually do the frame number thing again. And we're going to go all the way to 40,673. Oops. And hey, look at that. All of a sudden, once I have the binary file, right, this is after all the TFTP is done with whatever phones I had going on, we see that the phones are starting to SIP. They're trying to register with the SIP server. Now it's destination unreachable, ICMP destination reachable, port unreachable, because when they went out to the router for 5060, port 5060, the server wasn't actually running there. I was just trying to get the phones flashed over to SIP. So there we go. So what this tells me, though, is that my DHCP was handing out the right options, that the phones were able to get the TFTP servers that they needed, and that they started doing SIP as soon as they came up because I told them in DHCP where the SIP server was. So the next step really is to point them at the call server, and then life should be good. Okay, cool. What about the Ciscos? Well, the Ciscos are a little clunkier than the Avaya phones. So I did put the correct files out into the directory. And the Ciscos, as you can see, they were doing gets on all of the files that I had out there. for this particular configuration. But because I was just, I unzipped my Cisco files into the directory, what I was missing was a couple of default configurations here. Now, really, we can sort of ignore these two. We'll talk more about these next time, but these are actually MAC addresses. So when your phones come up and on a server you might do create CNF files, you're actually creating config files for the phones. But if you've never done that before, right, you have a default CNF file, which is what this thing is. And I did not have that in the directory. And what that does is it points it to the correct operating file so that the phones go, okay, I don't know what my settings are, but I know that I have this default zip file that I can use. Okay, so we'll solve that problem next time. But for right now, we are well on our way to the VoIP Cisco and Avaya phones. Remember that this was really all about the DHCP and TFTP configuration items. And then we took a look at some fun stuff with Packet Tracer. And of course, we looked through the captures. You can learn an awful lot by what phones are asking for. And for that matter, anytime some device on your network is asking a server for some value, take a look at what the server is trying to tell you, or take a look at the captures, and you can see what the devices are actually in search of, or things for which the devices are searching. Well, I think that'll do it for this time. Thanks for watching. Thanks for listening. Like and subscribe if I helped. And hey, may those TFTP and DHCP packets always reach their destinations.